Good evening everyone and welcome back. This is a nice question in logarithms. It might be easy to solve but has very interesting techniques I just wanted to discuss with you. Given equation to be solved is 2 minus x plus 3 log 2 to the base 5 which is equal to log 3 to the power of x minus 5 to the power of 2 minus x to the base 5. The first term has no logarithm. The second term has no logarithm. The third term on the left hand side has logarithm to the base 5, and the right hand side, the complete right hand side, has 1 log to the base 5. Alright, so I try to include log with 2 minus x. We know that logarithm of a number to the same base is equal to 1. So this 2 minus x could be written as 2 minus x times 1. Instead of 1, I could just write it as log 5 to the base 5 plus, using the power rule of logarithms, this 3 could go as an exponent here. So it becomes 2 to the power of 3, which is 8. So the only change I made here is including logarithm of 5 to the base 5 with 2 minus x, and I use the power rule with this term, so that 3 log 2 to the base 5 becomes log 2 cubed to the base 5, which is log 8 to the base 5, and I'll just write the right hand side as it is. Now, using the same power rule, this 2 minus x could go as an exponent here, becomes log 5 to the power of 2 minus x to the base 5 plus log 8 to the base 5 is equal to log 3 to the power of x minus 5 to the power of 2 minus x to the base 5. On the left hand side, we could use product rule. Log m plus log n could be written as log m times n, provided the bases are the same. So therefore, since we have log 5 to the power of 2 minus x to the base 5 plus log 8 to the base 5, this could be written as the product of 5 to the power of 2 minus x and 8, which is 5 to the power of 2 minus x times 8 to the base 5, which is equal to the right hand side as it is, right? So when you have a single logarithm on the right hand side and the left hand side, it says log 5 to the power of 2 minus x times 8 to the base 5, which is equal to log 3 to the power of x minus 5 to the power of 2 minus x to the base 5. You could just equate the numbers. Only when you have single logarithm on the left hand side and a single logarithm on the right hand side, provided the bases are same, you could just equate the numbers. So therefore, I would just say 5 to the power of 2 minus x times 8 is equal to 3 to the power of x minus 5 to the power of 2 minus x. I just rewrite this as 8 times 5 to the power of 2 minus x, which is equal to the right hand side. Now I just move this negative 5 to the power of 2 minus x to the left hand side, becomes positive. And we know that 8x plus or 8a plus 1a is equal to 9a, right? Just add them up, sum of the terms. So here we have 8 times 5 to the power of 2 minus x plus, I could just say 1 times 5 to the power of 2 minus x, which will give us 9 times 5 to the power of 2 minus x. I hope you guys follow me with this sum of two like terms. 8a plus a is equal to 9a. So 8 times 5 to the power of 2 minus x plus 5 to the power of 2 minus x can give us 9 times 5 to the power of 2 minus x, which is equal to the right hand side. Only 3 to the power of x is left over. So I just bring this to the denominator and replace 9 to be 3 square. So 3 square times 5 to the power of 2 minus x divided by 3 to the power of x and just 1 on the right hand side. Alright, because when this 3 to the power of x goes back to its original position, it has to be 3 to the power of x. Please do not put 0 here by mistake. It has to be 1 because it goes to the denominator. It could just go up and down. To the right hand side as a numerator, come to the left hand side as a denominator, right? Yes. Now if you see in division, when you have same bases, those two bases could be subtracted. So 3 to the power of 2 divided by 3 to the power of x, and the next step could be 3 to the power of 2 minus x, and we already have 5 to the power of 2 minus x on the numerator. So therefore we have on the left hand side 3 to the power of 2 minus x times 5 to the power of 2 minus x is equal to 1. Since it is a product and both the bases have the same exponent, I could just make it as a common exponent and just multiply the numbers inside the parentheses, because we already have a property says a times b to the power of m is a to the power of m times b to the power of m. So using that property, I just put this common exponent outside the parentheses and just write the bases as a product inside the parentheses here. Therefore you have 3 times 5 to the power of 2 minus x is equal to 3 times 5 to the power of 0, which is 1. So therefore, when you have the same bases or equal, you could just equate the exponents. Therefore, 2 minus x is equal to 0. Therefore, x is equal to 2. And any such equations you solve, it is always good to go back to the original equation and just plug in the value of x and cross-check if that particular value works or not. In some cases it doesn't, especially when it comes to modulus equations. I mentioned before that you have to check the value or the values of x in the given equation. It is good that you check in all equations that you solve just to make sure. And this is the end of this video. I hope you liked it. Please like, share and subscribe, and if you have any questions, please comment below. I will see you all in my next video. Thank you.